Alright, welcome to this tutorial on how to create still renders of your Rhino model in Unreal Engine 5. We're also going to look at some Unreal Engine workflow best practices. Some of the prerequisites are Rhino 7, preferably. If you have Rhino 5 or Rhino 6, that's fine too. I'm using Windows. This should also work on a Mac. The UI is just a bit different. You also need an intermediate level understanding of Rhino, and you also have to have Unreal Engine 5 downloaded and make sure that your computer meets the minimum specs required for Unreal Engine 5. You can find those on Google, and in the Google slides I'll include some important links. To begin, let's open up Rhino. With Rhino open, we're going to open up the perspective viewport, and we're just going to create a simple model. We're going to start with a 3-point box from the origin. I'm going to make it 3 meters by 3 meters by 5 meters. And maybe we have to type -5 meters here. I'm going to call this our object. And I'm going to switch from the wireframe viewport to shaded. I'm going to do a boolean to make this a little bit more interesting. So let's just do a copy of this box. I'm going to throw some random rotations on it. And I'm going to throw some random scales to it. So I'm going to go scale this by 0.5, and I'm going to scale this by 2. I'm going to select this object here. I'm going to make a new layer for my Boolean operators. I'm going to put this on that layer there. Just doing some best practices stuff here. So I'm going to select this, and I'm going to Boolean difference. I'm going to select this and click enter. Now if I hide my Boolean operator, I have my model here. Yeah, it's not bad. Actually, I'm also going to add something that's more curvilinear to it. So let's just add a sphere of some kind. I'm going to add it to this corner here, and I'm going to make it about 3/4 of the width. And I'm going to do a Boolean union. Alright, and then we're going to just merge all coplanar faces just to see if there were any, but there's not. So we have our NURBS model here, and yeah, that's what we're going to use to visualize in Unreal Engine. Alright, the next step here is to select your model, go to File, Export with Origin, and your origin is your pivot point in Unreal Engine. And if you don't do this, it's going to export the pivot point at 0, 0, 0, or the world origin. That's going to make it hard to do translations, rotations, scales in Unreal Engine. It's not so much of a big deal when you're just working with one model, but in the future, if you're working with multiple models, it can become an issue quite quickly. So yeah, you usually just want to pick a good location. I think this back corner is good. And then I'm going to make a new folder, tutorial. And in that folder, I'm going to put this and call it bulging box. If I spelled that correctly, I have no idea. We don't need to save the textures. We can save the plugin data. And yeah. Let's go with this. Click save. So sorry about that. We don't want to save the Rhino file. We want to save the FBX. So sometimes you export as an OBJ, but Unreal Engine prefers FBX files. So let's select FBX. Just do the same thing we did before. Bulging box. And it's going to prompt us for some meshing settings. if you hit preview, you can see what that's going to look like. Of course, because of this is curvilinear and polygons are planar, to create this curvilinear sphere, it had to add a lot more polygons than it did for the more orthogonal shape below. In future tutorials, I'm going to go over best practices for going from a NURBS modeling program to a mesh modeling program to Unreal Engine, but for now, I'm just going to leave it alone, and we're going to use this extremely messy mesh. We're not going to worry too much about UV editing or anything like that. It's just to do a simple render that still looks good in Unreal Engine. So yeah, let's just leave it like this and click OK. And our file's been successfully saved. Bulging, or maybe bulging, I don't know, box. And we can minimize Rhino. Let's open up Unreal Engine. So the Epic Games Launcher is where you're going to launch Unreal Engine from. I've assumed you've already downloaded it. So let's start by clicking Launch. And below that launch button, you would have seen the version of Unreal Engine that you're launching. I'm on 5.1.1. At the time of this tutorial, there's also 5.2 in its preview version, but which has some amazing updates, but I'm just using 5.1.1 at the moment. All right, now we're going to go down to Games, Blank. We're just going to create a blank project. These are template projects that are really useful if you're creating to just get some additional assets and code for like a more gamified thing. But since we're just doing a render, let's start with blank. For defaults, let's go blueprint, desktop, maximum, no starter content, no ray tracing. For our project location, I'm going to choose that folder called tutorial. And I'm going to give it the project name, which can't have any spaces in it, as Rhino tutorial. And click create. Okay, so now that the project's opened, we have this little message here called new plugins are available. Because we're actually going to be using a plugin, I'm going to suggest we go up here to edit, plugins. I'm typing in movie render queue. Click this checkbox and then click restart now. If you hit Control Spacebar on a PC, it'll bring up what's called the Content Browser. You can also access it by clicking the Content Browser button. This Content Browser opens up a folder structure, and this folder structure, if you open up the folder on the desktop that we saved the project to, mimics, so here we go, tutorial, the name of our project, Rhino tutorial, and inside of it we have a folder called content, and this is the Unreal Engine project file, and there's some other folders that aren't so important right now, but this one, content. Ignoring these two, this is where anything we add here is going to appear here, okay? The first thing we need to add is called a level. So what I did there is I just right-clicked in the blank area, and I'm going to select level, and I'm going to call it render example. One word again, or you could use underscores. Once you're in the engine, using underscores, it's personal preference, but using a style guide that's been created for Unreal Engine, the one that's like widely accepted by a lot of game studios, Epic Games themselves, and a lot of hobbyists, is to not use underscores really, except in between prefixes and suffixes, as well as like adding additional description to asset names, which I might mention if it happens, so I'll show you when that happens. Otherwise, you're just using like capital letters, render example, all one word. So if we double click this, and we don't need to save. Oh, okay, I guess we do. It opens us up a new level, and it's a blank screen, and we're in a void. So don't worry, we'll fix that in a second. But before we do, we're going to open up our project settings once again, go down to maps and modes, and change our editor startup map to render example and our game default map to render example. Even though we're not going to use any game related settings in this tutorial, we're just going to switch it anyways. We'll click save here. Alright, up here we can add assets to the project. These are ones that come already built into the engine, so we're going to click this. First thing we're going to go down to is lights and add a directional light, and we're also going to go down here and add a skylight. Nothing's happening because these lights have nothing to bounce off of, no atmosphere, no ground or anything like that. So what we're going to do is go and add under visual effects, and we're going to add a sky atmosphere, and we're going to add exponential height fog. We're also going to add a plane, and under the plane we're going to go to its scale properties, lock this, and type in 10,000. And we must be very far away from it right now, so with the plane selected we're going to hit F to zoom in on it. And its location, we're going to hit this to reset it so it's at the base. Oh, and we're just underneath of it. So yeah, so hopefully you've done maybe some basic tutorials on navigating Unreal Engine. I'm not going to go through that because there's so many tutorials online, and depending on how you learn, you're going to approach that differently. So if you skip that, the main thing you need to know for this tutorial is W, A, S, and D is what you use to move around, and it's going to be very hard to tell here because, here, let me just add a cube so that you can see that I'm at least moving. Okay, so W, A, S, and D help you move around the scene, and by clicking and holding the right mouse button and holding it down and looking around, that gives you the ability to look around. And then in combination with the keyboard keys, the W, A, S, and D, you can navigate. And so it's like a video game. The other important thing is that we have our camera speed parameter up here. You can play around with this to go faster and slower, but you can also just say I'm moving forward, so I'm holding down W, and if with my mouse wheel I'm gonna spin it backwards while I'm moving, that's gonna actually slow me down and speed me up. So if I go forwards, I'm going fast. Sure. If I move it backwards fast, now I move slower. So you can sort of micro control that scalar value. Alright, so we're just gonna delete that cube, and we're gonna go Control Spacebar to open up our content browser, and we're going to add by right clicking, we're going to add or import our model. So if you go to our tutorial folder, our box here, click open, we're presented with some FBX import options. Unless we're doing something that's translucent, or like just to keep it simple, unless it's translucent, you're going to select build nanite, and we can go through what nanite is in some future videos. The other thing we're going to change is we're not going to create a material from the import. We're going to do that on our own in a second. And we're not going to import any textures, even though there isn't any in that FBX file. And then we're just going to select import. And we're probably going to get a warning that no smoothing group information was found. As far as I know, you can't do what it's saying here from the FBX exporter in Rhino, which is to enable export smoothing groups. But we'll see. It's been a while since I've done this exact workflow myself, because I usually work between Rhino and Maya and then Unreal, so I'm able to overcome some of these challenges. But if this causes an issue in this tutorial, we'll fix it together. We're going to open up our content browser, and then we have our bulging box here. Double click it to open a preview, and actually it looks fine. UV mapped in the most terrible way possible. So we're not going to add any complex materials to this in this example, so don't worry about that. You can see what the UVs are if you already know what those are anyways, by just going up to UV here and looking at them. But yeah, it's a disaster. And UV channel 1 is light map UVs, but we can ignore that because we're not going to be using what's called baked lighting. We're going to be using real-time global illumination, lumen to be exact. And yeah, it's all good. You can see that that point we selected as our pivot is located at the center in Unreal Engine now, which is exactly what we want. So we can drag our object into the scene. We can go to its location and reset it. And then I'm just going to zoom out here. And there we go. This is going to be a static object, so we're going to select static. We might be getting this command here that says lighting needs to be rebuilt. To get rid of that command, we need to go to our lights in the scene and check that they're set to movable. And if it's still appearing, then we can run this command called dump unbuilt light interactions. Okay. So it's autofilling. We can click right click, and then in our log, lights with unbuilt 0 and 0. So this seems to be a bug. It shouldn't be appearing. So let's just go to type in disable all screen messages, and now it disappears. All right. You don't want to always do that because sometimes those screen messages are good, but we confirmed that we've done everything correctly and that our objects were set to movable, and so they don't require lighting to be built for them. Another thing we're going to do is create a material for this object. So to do that, we're going to go through a master material and what's called a material instance. First, let's create the master material. So select material. And now here's an example of a naming convention. A master material should start with the letter or a capital M underscore, and then whatever you want to name it. So I'm just going to call it simple material master. And then we're going to open it up. And if you want to learn more about materials, I suggest doing some foundation courses on Unreal Engine materials. There's a lot of these tutorials out there. I'm more concerned about teaching architecture and design specific workflows, which there isn't a lot of content for. So I'll let you do that on your own. And if you have questions of where to look, just send me a message. But we're going to do two things. We're going to create a color and set a roughness value. So to create a color, you can either right click and type in constant 3 vector, or you can just hold down 3 and it will create a constant 3 vector. For roughness, again, you can right click and type in scalar, or you can just hold down 1 and click. So we can drag in our roughness, drag in our base color, and we got a little preview going on here. So this is with a roughness value of 0 and a color of black. What we're going to do is we want to be able to adjust these parameters on our own. So we're going to convert, well, they're not parameters at the moment. So what we're doing is we're actually going to convert them to parameters by right clicking, selecting that option, giving it a name. And this one's fine, but on our roughness value, roughness is a value that only goes between 0 and 1. So 0 being really like black and very smooth, and 1 being white and very rough. So we're going to set our max to 1 and our default to 0.5. We're going to save that. master material, and then we're going to go and right click it and say create material instance. So what that does is exactly what it says. It creates a parametric material using this material as a base. So using the parameters we put in that file, we're going to create another material where we can adjust those parameters on the fly. So create material instance, prefix mi, and then give it a name. So I'm going to call this one our bulging box, or actually just object, because I don't know if that's even spelled correct. And we can open it up, and it looks a little bit different now. It just gives us our parameters here. If we click the checkbox on them for the ones we want to use, we can now go in and adjust these sliders. So if you've worked with Grasshopper, this is similar to that idea. And you can adjust the color. All right, that's how that works. So I'm just going to set this to 0.1, move it over here. And then if we select our object, go down to its material slots and select mi object. Give it a second to load, and now our object has that material. And in my other window, if I adjust the roughness value, and then go back, you're going to see that it adjusts in real time. We don't have to compile it again. It's all good. Now let's create our render. So if we go down to our content browser once again, and well, you don't have to. You can actually go up here and click create add level sequence, but we can just go here as well and go cinematics level sequence. Prefix ls, first renders, and I'm going to say renders because we're going to do a fun one afterwards. We open up that level sequence. We're presented with a timeline. There's a lot of stuff here, but all you need to do is create a camera. And when that happens, our viewport is actually going to start looking through the camera we just created. We can eject ourselves by either clicking escape, by hitting this button here. And then we can look back through it by going into the level sequencer and clicking that button there. We can adjust its focal length to something like, let's say 18. And with the camera selected either in the sequencer or in the outliner, we can change things like its film back to DSLR. We can change its exposure from auto exposure to manual. And when you do that, everything's dark. And our current aperture is 2.8. And so these are real world camera settings. And we have a sunlight in the scene. And we also have a skylight. So unless we increase the intensity on those lights, which you can do, and that'll work. That's one way of doing it. But what I like to do is, with the camera selected, and we go back to exposure, if we choose this exposure compensation bias, and just increase that to something that's not overexposed, not underexposed, but looks okay. That's usually what I do. And there's other ways of doing it, but let's keep it like simple for now. Our aperture then, if we increase it to like 8, you're gonna see it's gonna close the aperture on our lens, so it's gonna get darker. If we open it up, we're gonna get more depth of field, but it's also gonna get a lot lighter. So I'm just gonna go 5.5 maybe, increase the exposure again. And my focus distance, I'm going to select it. And actually, we don't even need to select it. We just need to search focus and select draw debug focus plane. And then as we move this value back in either in the level sequencer or here, this purple plane is going to pop into view, where we're going to see what's in focus and what's not. Everything behind the purple plane is not in focus. So I like some things to not be in focus in the shot. So let's go like 11, something like that. 11,000 centimeters or 11 meters away. And just to add some more things in the background, I might just eject for a moment. move around with the keys, and then I'm just going to go and add some shapes into the scene. We can select our camera and our focus plane, turn that off, and now you can start to see that if we bring our aperture down to something like, let's go 1.8, and then our exposure to 8 or 7, that some of these objects are actually a little bit more out of focus. We might have to bring that focal range back a little bit more. I'm gonna go about there. So yeah, I don't know, that was weird. What happens when we go back to our debug? Okay, I don't know. But it looks better this way. I might play a little bit more with the framing, so while looking through the camera I can move it around. Play with our focus range. Let's go 450. And then we just need to click this button here, and we're ready to do our render. Go to Settings. We're going to just choose JPEG. You can also choose PNG or EXR, but I'll go into those in more detail in future videos. For our directory, we're going to select our tutorial folder. We're going to use a custom playback range of just 0 to 1, meaning the first frame only, and the rest we can leave alone. The file name, it's just going to go whatever our level sequence is plus the frame number. You can go on, maybe I'll include that link, but there's some documentation on what sort of variables you can have here if you want to automate your file naming, but we can do it manually once the render takes place. Just click accept, but before we do that, let's save this as a preset to our content folder, call it photo master config, and we'll click accept. This way we can use it for another render in a second. So the other one thing to double check is it's going to render from this camera cuts sequence above. So make sure that your camera, Cine Camera Actor, is being displayed here. And if it's not, you might have to either click plus camera or right click and select the camera binding ID that matches your camera itself. Okay. And we can click save on our sequence, and then just well, maybe I'll mention quickly, there's an additional setting here that might be useful called anti-aliasing. By default in Unreal Engine 5 you're using, I believe it's called TSR, temporal super sampling, as your anti-aliasing method. So by default your render is also going to use this. But if you want to improve the quality of your render, you might want to select override anti-aliasing and then increase the spatial and temporal sample count above a combined total of 8 samples. And I'll include a link to more information about what spatial and temporal sample counts refer to and what effects they have. But I honestly think you'll get a fine render just using TSR. And we'll click accept. And maybe we'll just we'll overwrite our PhotoMaster config with our anti-aliasing, even though it's turned off. Okay. And then we can click render local. It's going to take a second to change or to compile shaders for the highest scalability settings in Unreal Engine, called cinematic. You can sort of see that it switched our scene to that here. It only has to do this the first time, and once this finishes, it's going to be very quick to render one frame, because Unreal Engine is a software that's used to rendering like 60 frames a second very easily. So we're already done our render. If we go to our File Explorer, Desktop, and our folder, then we have our render here. See, it was named the name of our level sequence .0000, meaning the very first frame. We can rename it. We'll call it bulging blocks landscape. and open it up. And we have a render. Not the best one. It's very, the resolution is not great at all, actually. So let's see what's going on here. We open up our PhotoMaster config. We have our resolution. Okay. That's fine. JPEG. We're not overriding anti-aliasing, so I think it's just the resolution. It could also be our focus. So let's maybe, if we type in focus again and draw our debug plane, let's use this purple plane as our actual focus. So let's go here, 24,000. Let's go render local. Okay, here's our new render. Yeah, it's just we're so far away that only this many pixels is. So we'd have to increase the resolution to get a clear render. So I'm just gonna delete that one. I have a feeling that our object came in from Rhino, even though it was in millimeters, and if we do distance, it's 3 meters, but I think it's being scaled incorrectly in Unreal Engine, but let's not worry about that for now. If you do want to adjust this, just go into the static mesh asset. If you scroll down here to import settings, transform, and you import uniform scale, if we change that to 0.1 or a tenth of what it imported as, it should be correct. But we're just going to leave it for now. And I'm going to turn off this focus plane. Now we're going to save it. Go here. And we're going to render. If we go to our desktop tutorial. Alright. It definitely doesn't look super great, but in terms of quality, but that's okay. Let's change some things here. So let's make another shot that's, let's add a couple fun things and see if we get a better render. If we rename our camera, prefix CA, bulging box, and we'll call this one long, and we duplicate it, Control D, and we call this one wide, and then we right click here, properties, and change it to wide, and then track our wide camera, so it says, okay, here we go, bulging box wide. Let's change our focal length to something like 8, which is very wide. Let's go inside of our object, maybe like, let's go here to visual effects, volumetric clouds. Then let's make a material for the ground here. So what we can do is actually just go to our MI object, duplicate it, and we'll call this one floor. Then if we go down here, select our floor, materials, MI floor. Now we've adjusted the floor, but if we click that, it's a different instance than our object. So we can change its color, and we can change its roughness value. I'm going to go with something like this. Click save. Under my bulging box wide camera, with it selected, I'm going to search for crop. I'm going to switch the cropped aspect ratio to something that's portrait. So a lot of DSLR cameras shoot in 3:2 aspect ratio. So if we type in 2 divided by 3, it'll give us that ratio for a portrait shot. Then we can line it up here. This is something we like. I don't know. Sure, let's just do that. And with it selected up here in our camera cuts track, we can open up our render settings. We're going to have to change one thing, and that's the output resolution. Instead of 1920 by 1080, we need to figure out what the HD pixel ratio is for 3:2. So I just going to go to Google and type in 3:2 HD pixels. 3:2 ratio is 1080 by 720. Yeah, that sounds right. So 720 is going to be our width and 1080 is going to be our height, but we're going to multiply this by 2 to get 2K because that gave us HD or 1K, and we'll hit accept. And unless we save this, this is only going to work for our current session of Unreal Engine, so that's okay. We're just going to hit render local. Boom, done. Let's see how this one turned out. That was our first render, our new one. Yeah, not so bad. And we can just call that one lodging box vertical. Great, so we actually have two. Our first landscape one, which is our first go at it, not so good, and then very quickly, just by adjusting a few settings, we have a much nicer render of whatever this is. It's not architecture at all, but this is about just teaching some of the basic concepts. Couple last things, some best practices. We started getting into some of the naming conventions, but another thing we're going to want to do is clean up our content browser. So I'm going to create a folder, and you usually create a folder called maps where you store your levels. Click OK. We create another folder for geometry, and that's where we store our static meshes. We create another folder for our materials, and that's where we store our materials. And we create another folder for our, I call it cinematics usually, and that's where we store our level sequences. And then our config, I mean, you could put this in the cinematics folder as well. This is how I like to structure things usually. Everyone has their own opinion. There's no real true way of doing this other than maps. It's pretty common to put your levels in a maps folder. And yeah, that just keeps us organized for next time. The other thing we'd change is our bulging box name. We'd probably give it the prefix SM. Bulging box, one word. All right. And other than that, everything's good. We can save this. In your outliner here, you might want to clean that up. Like, I like to rename instances if there's not too many by going like this as well, just to keep things clean. And what I'll usually do is create another folder here called geometry, where I'll store my geometry. And then I create another folder here, which I usually call environment, where I'll store like lights and things like that. So that cleans up the outliner, and now you have a nice file to work with, and that is the gist of things. I hope that really helps, and thanks for watching. And next time I'll do some more Unreal Engine stuff for people that are used to working in Rhino. So